Welcome everyone. This is, as Nick said, this is our academic panel. I think we have four great academic participants. Hopefully, at least three. And so I will start with the introductions. I'll just we'll go down from right to left. So Dinesh will be last, and I'll briefly introduce each one, and then give them a chance to provide a little more background about themselves, and in particular, their interests with regard to spectrum, which is sort of the theme of the meeting today. So first we have Dipankar Raychaudhuri, who goes by Ray. He's a distinguished professor at WinLab at Rutgers University, the former, I guess, the director emeritus of WinLab, which is a large wireless research center that many of us know at WinLab, at Rutgers. And so Ray, go ahead. Tell us a little bit more about yourself and your interests.
Hi, Randall. So good to see all of you here. I have been working on Spectrum for the last 20 years or so, mostly on the protocol and algorithms aspect, but more recently we also did quite a bit on measurements and testbed use, and trying to verify some of the ideas that were analyzed by simulation in the past, gradually going up to emulation on testbeds, and then eventually we may look at some outdoor tests as well, especially in our Cosmos deployment at Columbia. So my focus nowadays has been on this. We have a project under New Spectrum, which is about a data-driven architecture for spectrum use. And I think a lot of the elements of that are similar to what others are doing in SpectrumX and other projects. The focus particularly is on creating the syntax and protocols necessary to achieve good spectrum sharing without making it very centralized and complex. So we have a distributed algorithms focus in that New Spectrum project, and we're trying to work our way up to these kind of trials or field trials, as the case may be. The project started 6 months ago, so we still have time to go, and we're planning to do those kinds of things. For the community as a whole, we recommend looking more at standards for describing spectrum, like the consumption models that my colleague has been working on at Rochester, Carlos. So you may have seen some of that work. The idea is to kind of have a set of standard descriptors and protocols that can be used to have a shared view, a common view of what spectrum sharing involves. It certainly is moving more to data-driven architectures like this. So we can talk more if the topic comes up. And Randall, I'll hand it back to you.
All right. Thanks, Ray. Looking forward to it. Next, I'll move to the left to Kaushik Chowdhury, who is currently the Chandra Family Endowed Distinguished Professor of Electrical Computer Engineering at UT Austin. Many of us have associate him with Northeastern for many years, where he was also heavily involved in the power test beds and other activities there. So, Kaushik.
Well, thanks, Randy, and excited to be here. My interest areas are using applied machine learning and a systems approach to spectrum sensing, signal analysis, and coming up with interesting coexisting scenarios. And as part of some prior work that has led me here to this point, I've been part of the Power Program Office when I was at Northeastern for many years, and seen upfront at least in the front, and having a front row seat as to these different infrastructure that exists that allow the community to collect spectrum measurements and make analysis on them. I've also been part of some large investments from both DoD and the NSF space in the spectrum environment. So I was co-PI for the NSF Coliseum emulator, which was it's an excellent space to try out interesting signal on signal sort of experiments and data collection. Originally part of the DARPA Spectrum Collaboration Challenge, and then NSF supported its transition over for more research use. And currently, I'm also leading this NSF RF data factory effort, where we are trying to come up with ways in which we can store, collect, disseminate data sets, RF data sets, but also provide APIs for the community to build and generate their own data sets and localized spectrum data collection platforms. In all of this, I continuously see the value in the ability to acquire and disseminate large RF data, and that's the angle I'll bring to this discussion. But that said, we are at an exciting opportunistic point where we can leverage new tools that we did not have 10 years ago when I started off or so in this area. So what these new tools, and I'm referring to with a hint and a nudge at machine learning and so on, which I'm sure we cannot escape in this panel at all. But we'll talk a little bit about the role of what these tools and the challenges that we have in using these tools in advancing spectrum science and adoption of spectrum measurement technology. So we'll talk more about that in a bit. So with that, Randy, I'll give it back to you.
All right, thanks, Kaushik. And moving next, we have Eric Berger. Eric is a professor at Virginia Tech, where he's also the director of the Commonwealth Cyber Initiative. And he is a professor of both electrical and computer engineering and public policy. And so we know policy and technology are sort of critical for spectrum. And I think Eric brings some great insight there, plus a nice resume of government experience. So I'll turn it over to Eric.
Well, again, thank you, Randy, and recognize a lot of people in the audience. So thank you for spending your hour out of your many hours of SpectrumX stuff with us here today. Yes, Randy, the public policy thing is important when it comes to spectrum. We've been looking at spectrum sharing. We've been looking at spectrum clearing. And I can say, for example, the AMBIT program, which opened up the 3.5 gigahertz spectrum, was in fact more of there was a lot of technology and a lot of technical analysis behind it, but at the end of the day, it was a policy shift that enabled the sharing and virtual clearing of that spectrum. And that's is very informative of a lot of the research I'm doing now, which is we can come up with magic sharing pixie dust that just doesn't get deployed, or people sit on spectrum that they don't have to, and so some of the controversies that were done during my time and still haven't totally gone away, as I am a licensed instrument rated private pilot. So, radio navigation is very, very important to me, and interference could end poorly for me personally. At the same time, and this is where a lot of Kaushik's work comes in, and Dip's work comes in. The question I would keep asking is, well, what is the impact? How do we know? And quite often the answer is because that's what I feel like, which is not a way of setting policy. So we've been looking at a lot of like the physics in the 12 gigahertz band, a lot of ways of doing notification without revealing who needs the spectrum, but yet you're confident that they really need it. So a lot of privacy preserving techniques there, as well as novel economic models that might get us out of a perpetual cycle, to enable things that SpectrumX is leading some of this research on things like low power indoor use. So no, I'm looking very forward to the conversation today.
All right, thanks, Eric. And I did see Dinesh is here. Did you get your camera to?
Not yet. I will just momentarily, I will try to get a Zoom update on another machine, but yes, I can begin.
No problem. I'll move on and introduce you, and then you can try. So Dinesh is a faculty member at UC San Diego. Just one comment I'll make is he did some award-winning work on full duplex radios when he was a PhD student, and was also involved in some efforts at commercializing that. And so, and recently has been quite active in the spectrum area. So Dinesh?
Can you guys hear me?
Yeah, we can hear you.
There we go.
Yeah. All right, let's try. Okay, all right, it worked. Okay, I guess you have to maybe, I thought I would get away with showing my younger picture and just go with that. But okay, so this is how I look after aging, right? So I've been working mostly on, let's say, a lot of hardware related efforts when I started with my PhD, and more recently transitioning into doing a lot of software and networking. And more precisely in this context, we actually were building this really cool system together with, let's say, IARPA's funding called Scissors. We essentially built this 4 gigasample truly distributed spectrum sensing solution, which essentially processes all that data line rate and gives you insights from all the way to where hidden cameras are in your environment to sort of several other things in your environment which are anomalous, right? And also provides true understanding of what's going on your spectrum, right? I think so. This is something really has been very interesting for me, and this is where I'm hopefully happy to hear a lot of thoughts and discussion today on this forum, and see how I think right now we are open sourcing this platform in the sense of you can bring in your SDR, hook it up to your internet, and we automatically will have it set up in our system, and we will have another class or set of users who are essentially trying to do different types of experiments, right? And they can get AI ML tools along with a lot of distributed processing, right? And they can sort of get insights of, let's say, how good is satellite signals in San Diego, in indoor, in my office, or several other use cases. You can easily answer those questions, right, with this framework, right? And I think happy to send a link to join that platform and how you can use your SDRs and put them to good use and put to the community for larger use, right? And with that, I'll pause and maybe hand it back to Randy and let's sort of get the discussion. Sorry, I'm just ran to my other office because the camera wasn't working. So I was transitioning and getting this to work. Okay. All right. Back to you, Randy.
All right. All right. Thanks, Dinesh. Catch your breath. Thank you for getting on. All right. So the goal here, as Nick said, is to gather some eminent academics from outside of SpectrumX and to get their opinions on sort of the state of spectrum research. I would say both looking back and looking forward. And so with that in mind, I thought I would start with looking back. And this year, some of us are involved with the IEEE Diceband conference. It marks the 20th year since Diceband started. And I think that's roughly, going back 20, 25 years is when the wave of spectrum-related research involving, cognitive radio, spectrum sensing kind of started. And so I wanted to take a minute to ask everyone on the panel, what do they think about looking back? What have been successes that have come out of that? What have been shortcomings and what are, what are problems that we can see? So anyone want to volunteer, or I can just call on people? I'll call. Eric, you're smiling. You can go first. You look like you have something you want to say.
Yeah, even though sometimes people don't think it, I still think CBRS is a success. We put a new model on the world. Some can argue the UK has done it better, but I don't think they would have even tried without the work that was done probably about 15 years ago. Actually, yeah, probably about 15 years ago to get that ball rolling. Took way longer than we thought it would to get it out there, but I think that I would say is definitely a key success.
All right, good.
I could go next if you like, Randy. It's funny that you mentioned the past of cognitive radio. I was looking back, I was on my trying to find my PhD thesis on the shelf, which actually had cognitive radio in the title. It was, 15 years ago, but the fact is that the fact that we are continuing to work and advancing this area of intelligent radios. Now, the wordings may change. There may be a new word that we describe it now, but the fact that we are still on it shows that this area has a certain longevity, and we are far from solving the problems. Now, what we have now is what we shouldn't carry over from that era, that when I was perhaps still a student then, is that we were assuming certain fixed models that allow, here are concrete tolerances that you cannot exceed, and this is the maximum sensing time that you are allowed. So we are seeing erosion of hard guardrails of including what spectrum we might try these spectrum sharing kind of technologies on. We are looking at can we offset fundamental hardware-centric limitations with other tools like learning and adaptation, where we can do the best we can in hardware, and then have another step, which is a sort of a more a recovery step, if you may call that, using other kinds of tools. So I think we are becoming more flexible in the way we are looking at the problem and accepting of other degrees of freedom, including software-centric view, and embracing that spectrum as a whole could be shareable, instead of just certain bands of white space or of certain bands of just allowed use. So I'll pause here, and then I'm sure we'll have more conversations.
All right. Thanks, Kaushik. How about Ray, Dinesh, any thoughts?
Just want
good.
to add.
Okay.
Yeah. Go ahead.
No, please go ahead, Dipankar.
Okay, so I just wanted to add to what Kaushik said, that I think we witnessed a gradual success of this cognitive radio idea. I didn't use the word cognitive as much as software-defined radio, but I think just as there are parallels in the wired networking field where SDN became a reasonably well-accepted industry standard and concept, and then after that it resulted in an ecosystem that people could contribute to and build on. So I think what we are now witnessing with Spectrum is that you have software-defined radios as the norm. So you can do a lot of things which couldn't have been done before. So I think in that sense, okay, so I see a question, we can get to that afterwards. So in a general sense, the software-defined paradigm has expanded quite rapidly in recent years. There's this ORAN alliance which has come about, and that it does many things, but it also can do spectrum quite well. And there's some issues of how fast it can run for other applications, but at least for spectrum, I don't think computing will be the bottleneck. So I guess that's the direction that we see the industry going, and perhaps this will result in a more kind of well-accepted standard interfaces, as well as syntax for protocols which use spectrum consumption models or things like that, which are actually being standardized by IEEE. So there's a lot of pieces to that. Thanks.
All right. Thanks, Ray. Dinesh?
Yeah, I think to be precise, maybe I'm not as, I guess, let's say, seen this, right? But I can, from an external point of view, this is what I see, right? I think there were a lot of great ideas, right? Actually, to be precise, in 2009, I was a summer intern in University of British Columbia working with Vijay Bhargava on some of these ideas of relaying in cognitive radios, right? I think the precise change, at least I see what has happened, is that with all of the software-defined radio and all of, let's say, programmabilities in the radios, it has allowed us to prove perhaps the existence of CBRS and other spectrum sharing mechanisms is feasible and can work in real world, right? I think this is a very precise change which has taken up and about, right? And that I think now makes people believe, or at least you can prove, right? Okay, even if maybe often it's very easy to like make, or it's very hard to make policy change, right? More precisely, right? And this type of real data truly helps you making a shift in the policy, right? I think this is where I see this is the confluence of a lot of programmability on one side and ability of having these platforms and experimenting by ourselves allowed us to make real points, and which I think now are not on. One could argue either ways on like, hey, this won't work or this would work. But with real data, there is a clarity that whether it would work or not, right? Or at least much more clarity in this regard, right? And that has maybe caused this shift, right? And we are at an interesting time where now we can really push this really fast and really into cool innovations, right? I think, and we should leverage that, right, before this runs out, the time runs out in some sense, right? In the sense that, that like it's always a counterbalance between computing and communication, right? Okay. And I always have been looking at this from this view in recent times, but I'll pause for there and then maybe hand it back to Randy for now.
Okay. All right, great.
Randy, there was one question which I could answer now or later, whatever you prefer.
So let's see. There was a question as regarding a point of making models more flexible. How do you see this has evolved the interaction between the models and the business and economics of applications? I think that is an
I think that's a good lead off to your next segment, and maybe you can start, we can add to that.
Okay. So yeah, does anyone want to answer that right now, or do you want me to just move ahead?
I just put a note there just in case, if I'm interpreting it correctly, it is like how do models from other communities, perhaps completely different domains, can be adapted and used. I'm interpreting it that way. You can interpret this question various ways, so I'll let the person decide. But okay, good. But I just wanted to say that we are continuously being inspired by all these different domains. You know, a lot of the models, in fact, that we have all used in the DARPA RIF mills, IARPA scissors, etc., were at some point designed for an image processing community or so on. But I just want to say it's not just the model architectures. It's about the pre-processing of data that we should significantly focus our attention on, like, you know, how do you handle complex valued IQ inputs? How do you augment the data meaningfully? You know, how do you do batch processing in a way that consumes live feeds, because it'll quickly overwhelm your storage. So let's pay as much attention to data pre-processing as well as the model design in terms of the architecture design. So, awesome.
All right, thanks, Kaushik. So the first question, we were looking back. I guess the next one is a broad question for the whole panel of looking forward. I think you alluded to some of this already, but you know, if you look forward to the next 5 or 10 years, what do you see as the most promising new directions in spectrum research for academics? We can go backwards this time. Dinesh, why don't I start with you?
So maybe just Randy, maybe you can repeat a little bit more of what you're thinking here, and then maybe I can comment on that more precisely. I was just thinking about the previous point, and I have some interesting bit to add. But go ahead, yeah.
So I was asking, looking forward, say looking 5 to 10 years forward, what do you see as the most promising research directions that we as academics could be contributing to in the spectrum?
So, I think I'll maybe try to answer the two questions, and this is maybe just clicked as, I think I was just thinking of, like, let's say GPUs and how back in 2010, I would just be using them for primarily just to do gaming or some sort of that form of just watching very high quality movies, right? I think, and they have now transformed into these giant beasts, which essentially drives the next economy for revolution for us, rather, right? I think the precise point for us is, so like the way at least I see is that I can use today these SDRs, right, and make them anything from a 5G base stations. So we have been trying to make this very low cost SDR together, to try it with ARPI and build some effort. I think even Ericsson has undertaken, right, to sort of build a very low cost 5G base station, right? Okay, as cheap as your Wi-Fi access point, or even cheaper to be precise, right? But it's a short range sort of connectivity, right? And then there is nothing, and you can build these things, right? The point at least I'm trying to make is that if you think now this into fast forward the next decade, right? Okay, combined together with a lot of the computing power we have together with the SDRs, right? Okay, we can truly pair them up to achieve, let's say, forms of like universal radio, right? Okay, a radio which can talk all protocols, all languages, right? Protocols are pretty much like languages, right? Different people sort of talk different things, right? And different languages, sort of like doing the same thing, right? With, let's say, all of these flexible radios. And this truly transform how we use the spectrum as well, right? In real time, if we can negotiate what spectrum to be used, how to be used, what sort of language to be talked, right? I mean language as a protocol, let's say Wi-Fi, Bluetooth, or whatever, right? You could have a single sort of radio interface powered with computing, truly transform the entire landscape of how we connect with things, right? And then this can then go across, let's say, form of devices, not just, let's say, large scale desktop devices, but small scale RPIs and other devices to very, very small watches and other things as well could sort of be the way to transform all of this, right? Just to give you an example, I was talking to a computing company, right? I think, and what they were, it was very interesting. All BLE decoder right now has transformed into way of that directly runs on sort of ARM processors, right? They don't have any more, let's say, ASICs for a lot of class of BLE decoders right now. And this is actually a very, very strong signal to that general purpose computing kind of things are best way to go about interfacing with the radios and doing the rest of the communication system, right? I think it has always been a traditional view of using application specific integrated circuits to do these communications. But now we are gradually moving into that nudge direction of, okay, using these general purpose computing architecture to run a lot of our decoding algorithms, right? I think we are still far away in the sense of like 5G and others are really, really compute hungry. There is NVIDIA's solutions for a lot of doing these LDPC decoders on GPUs, but they are still like the cost point of those to this is not as much comparable, right? Or the current Intel ACC 500 type of things where you do LDPC decoder literally on an FPGA card, which is close to an ASIC, right? Okay. Now, the point at least I want to really step back and say is that like we are already at Bluetooth being running on the ARM core processors, right? I think we are into this world of getting into launching into universal radios, right? I think, and this by definition has a reverse impact of we can use these devices for universal sensing as well, right? I think so. A lot of our work in IARPA showed that we can use these radio signals to also detect a lot of spy devices in our environment, right? Or we have been, our community at large has been working on using radio signals to detect people, things around us, right? I think sort of thinking of this universal platform, much like GPUs, which you plug in your desktops, your microcontrollers, or different types and different forms, right? And it can truly provide not just connectivity, but understanding of your environment, right? Okay. That's sort of the future I think we should be driving towards, right? Okay. Maybe a long-winded answer, but hopefully made sense, right? Yeah. Maybe back to, I guess, you, Randy.
All right. No, I like it. I like it. It's a very, very, very bold vision of right, what happens when these things become very flexible and very cheap. Right? Nice. Anyone else want to jump in?
Well, of course, the answer of what's the most important in the next 5 to 10 years is whatever I'm working on, isn't it? But in fact, what I did want to highlight, and there are a number of members of the Research Council on this call. The Next G Alliance has a research council. It's made up of a number of academic researchers and a number of industry researchers. And one of the things that we're working on literally right now is what are the big research challenges that, we as a nation, and actually NGA covers North America, so including Canada, what do we need to be focusing on? And not a surprise, spectrum and the technologies that open up even more spectrum are pretty high up on that list. We've been doing MIMO for a while, we've been doing AI ML for a while, and now we're seeing a lot of AI ML MIMO. And on the one hand, is that spectrum? Well, it enables the more efficient use of spectrum. I will pile on to Dinesh's point and going in a all of the above direction. There is a lot of value and interest in going to the ultimate SDR, so to speak. At the same time, we have to understand that the economics of general purpose computing is more about the economics of IT. Because if you look at a lot of the bespoke hardware, it's still a ARM processor with a GPU with a whatever, but it's running embedded Linux instead of Ubuntu. As long as that's fast enough, and as long as the thing we're now starting to really focus on, as long as it's energy efficient enough, it's great. And there's still a lot of things that more bespoke solutions, whether that's going down to the FPGA level or all the way down to the ASIC level, we still see need for that, which means we still need research on things like analog circuit design. There really is still an analog world out there. We really still need work on how can we do more energy efficient computing, whether that's more at the computer science level or more at the circuits and signals level. So there's a lot out there that's going to affect Spectrum over the next 5-10 years.
All right, thanks, Eric. Kaushik, you got any thoughts?
Sure, yes. So since you are asking me to project the next 10 years, I'm going to pick 3 concrete research topics that I think if there's a student sitting here, please consider them. One is advancing the kind of spectrum science that could only be possible using these newer kinds of machine learning tools. Now, for example, what I'm talking about is capturing spectrum measurements is difficult. You need highly precise hardware and tight synchronization, localization, very good calibration. It's not all of us can have it. So could we use newer tech tools like generative AI and diffusion models in particular to extrapolate measurements from one band to another if the hardware devices are co-located? This is a fascinating area where we can cut down on new spectrum measurements considerably by using these tools. So that's number one. Number 2 is let's find ways so that the spectrum that's already being used can be commercialized beyond communication. So I'm talking about integrated sensing and communication. So if there are ways in which spectrum can be repurposed for other kinds of tasks, it might unlock a whole new economic opportunity, but also new kinds of research that these services need to coexist on. And you have to do it without harming the other, which is, I think, the key challenge. The third one I'll say is let's figure out in the next 10 years how to share RF spectrum data effectively and easily and design methods. And I have some thoughts in mind. Those could be perhaps some not raw data, but maybe embedded features or extracted features from this underlying data, which can overcome some concerns of privacy and such, but enable sharing of spectrum data. And without this, I fear that a lot of innovation won't be able to be unlocked effectively. And just want to say that there are a lot of good NSF-funded platforms, as well as an upcoming a large effort led by MITRE in this domain, in this the testing and evaluation of this national radio dynamic zones. I think those will be critical in advancing spectrum science along these 3 axes that I feel are extremely important. With that, Andy, I'll give it back to you.
All right, thanks. Definitely some things that that we've been thinking about in our flagship efforts too that I think resonate with what you've been talking about. Ray, do you have anything to add?
Yeah, I just want to mention here that the process of making spectrum research more data-driven, as Kaushik was also pointing out, it's a long haul from where we are today. There are a lot of very specific interfaces and systems, but none of them are generalized very well and become open software solutions. So I think that for the industry as a whole, 5 years is the next 5 years, I would say, should hopefully start to see emergence of an internet-like model And I think internet is a good comparison, not because of the technology is very different, but this is also something where you have autonomous domains or independent domain providers who can benefit from coordinating with spectrum nearby, and you can have better quality spectrum in new bands, like say 6 to 7 gigahertz kind of numbers. So those could become much better utilized, and if things go right, and you don't need something that involves a very heavy-handed regulation. Instead, you'd like to have an architecture that enables users to coordinate in a local area. And there is a kind of a scalability that comes about if you do the right architecture. We have been working on a concept called the wireless control plane. And if you can get people to buy into a couple of standards of that, you might be able to coordinate locally without requiring any central entity. So we have routinely been sort of pushing back on the notion of highly optimized spectrum, which is centrally administered. And there have been attempts to do that, but maybe they don't all work as well as we think. And there's a scalability issue that if you start to have thousands of devices in a small area, which is true in most urban metro scenarios, you really cannot get good results with the present model, where everything is centralized and somebody has to compute and assign bands to people and time slots and whatever frequency. So all of that, of course, the theory says that you can do very well centrally, but the distributed approaches are much more difficult and will require sort of new protocols, which also bring in the element of economic partnerships or economic models, incentive systems that Randy and others have been working on as part of this overall NSF funded research community now. So we think that it will be interesting also to look at interfaces like SLA equivalent to the internet model, where you have in this case, the service being provided is a spectrum as a service rather than packets being delivered. So it can be an interesting thing for some people to work on. And once you have an SLA that is rich enough to describe different kinds of business interactions, that will go a long way to opening up some of the things that haven't happened in the world of shared spectrum, and we're still waiting for the really big adoption to occur. Hopefully that will happen in the next few years. Okay, that's what I had.
All right, thanks, Ray. I'll circle back to some of the economic stuff a little bit later, because it's dear to my heart. But I wanted to pick up on a point you and Kaushik just made about having data that's easy for people to access and out there that's available. And I guess given your experiences with power platforms, I think that was also sort of a desire there, was to have things that were easy to program, maybe easy to get data from. Are there lessons to learn from that experience, things that we should be thinking about as we try to move spectrum in that direction?
I'll let Dinesh go first. He's certainly has more experience on that.
No, I will. Why don't you go ahead, Kaushik, please? Yeah.
No, look. So I feel we are uniquely poised, especially with the power platforms. That data collection becomes easy, right? It's a few clicks, beautiful instrumented system. But then there are other questions on. It is not just collecting gigabytes of data, that of RF spectrum data that's going to be of any immediate meaning to you, right? There has to be automated tools that capture, annotate, find signals of interest, and generate metadata for those specific points of view. So the ecosystem of just collection cannot just stop there. It has to be extended to some sort of a spectrum analysis and metadata generation. So we still need some work on bridging that automated metadata generation along with this, right? So that's number one. Number two is there is always going to be a need for localized testbeds in in addition to large-scale experimental facilities. And the reason is you just cannot replicate the kind of controlled environments that you would like for some forward-looking research. For example, you want a very specific radar signal interfering with an LTE signal, right? Now, you cannot do that right now in many outdoor deployment places. Perhaps in the new NRDZs, you can study some of those controlled experiments outside under more controlled environments. But still, you need software APIs for your own indoor labs that allow you to create those environments quickly with just a few touch buttons, right? So what I feel is while spectrum acquisition tools are maturing, generation of scenarios with respect to where those tools will be deployed are not flexible. And so we need flexible creation of scenarios and flexible annotation of those scenarios alongside just capture, the capture effort. That I'll give it back to you, Randy and Dinesh.
All right, great point. Anyone else want to add to that, or we can move on? All right, I would so Curtis I think posted a really good question in the chat. Curtis, do you want to unmute and ask that, or I can read it for you?
Sure, that works. I think, yeah, so I mean, obviously Dinesh and Kaushik, you were involved in Rift Moles and Scissors, so maybe some folks others are familiar, but the thing that I observed as being on the T&E side of that was the multidisciplinary teams focused on the systems engineering to get these solutions tended to have, led to the more robust solutions. And so, as academic leaders, and especially maybe in a minor in industry, looking to hire your great grad students that are going to get your degrees and knowledge, how do you think about training those multidisciplinary students? I'm sure you guys have structures already in place, but just projecting forward to the future, I guess, is the question.
I'd love to jump in on that.
Yeah, is it Eric? That seems up your alley.
Yeah, so part of it is, and some of you know the person, Shaki's Law. Money's the answer. What's the question? NSF is funded, and NTIA has funded, and DoD has funded a number of explicitly multidisciplinary. Your proposal will be rejected if it's not multidisciplinary. And more to Curtis's point, though, yes, EE and CS is multidisciplinary, but the real innovation, I think, happens when you bring in the economists, you bring in public policy people. I mean, I will suck up to the hosts today. Look at the composition of SpectrumX. It's not just double E's looking at waveforms. And so I'm thinking right now of a project I've got where I've got a public policy PhD student with an ECE PhD student with two ECE master's students working on a project. And, when the public policy person asks that innocent question, that then, results in a breakthrough. Besides the, those funding structures, the structure of SpectrumX, the structure of the Commonwealth Cyber Initiative, the program that I'm research director for, we again tend to say multi-institution, multi-discipline is kind of like the minimum for our seed grants, because that's what we see makes the breakthroughs and gets the funding.
So maybe I'll say one thing which works for me from experience is really, I think I tend to work with some number of undergrads. I think it's really fun, right? They really want to build things. And I think they therefore are very excited about learning the systems and EECS side of things, right? Okay. And I think what works for me is that gradually nudging them into, hey, do you want to take this class or that class, right? I think along with the parallel activities that they undertake in the lab sort of motivates them to keep pushing themselves forward and get themselves trained. I think it's just become very easy, or it's not easy, I would say. But for me, the best students now I get is through my own undergraduate program, which I've sort of been nurturing them from first year, right? And I also encourage them to go out there, go to different schools, right? I think it just sometimes they have roots in San Diego that it becomes harder for them to leave, but some of them do leave, right? I think, and some of the colleagues have always like, hey, why did you let this student go to somebody else, right? I'm like, I think it's better for him as well as student, right? I think he would really spread his wings, right? Learn from different people. He has just already learned whatever he needs to learn from me for like last 4 or 5 years as an undergrad, right? So to me, that seemed to have nurtured at least set of undergraduates, right? I think, and some of them I'm really, really proud of. They are right now out there at Columbia or a few other schools I know of, right? Okay. I think they've been doing fantastic stuff, right? And then, yeah, so this is what I think works well is that we just take the initiative of training them early on, right? And just, it takes maybe a small time. Hey, what classes they have very simple questions, right? What type of careers I can get into, right? And what classes I should take, what would help me optimize to get into this career path or that career path. I think, yeah. And then some you find very, very good students, right? So this has worked in, let's put it this way, more practical, small practical experiment in some sense. Yeah. Back to you, Randy.
All right, thanks.
Randy, maybe I can say one word, a shameless plug-in for academia in general, right? Academia is really the cradle where we produce some forward-looking ideas. Many of them may not work out, right? But we also produce that, what Curtis is referring to, a trained workforce, which will then go into industry and do better and greater things. Hopefully make some money, right? One thing that some of us, at least in academia, wouldn't know as much of. But the takeaway message is create, and this is a message to also to the representatives from government agencies who are here, create programs that allow academia to participate and be part of these larger efforts. For example, Scissors and Riff Mills are two examples where, as academic teams, we benefited, but hopefully we also contributed in some ways. We also produced these engineers who have now gone on to do much better and greater things than our advisors, as we as advisors could ever. So give us, in general, academia an opportunity to be part of these things. With that, let me get back to you, Andy.
No, great point. Great point. I think there's to your point, there's the value that we as academics contribute to these initiatives, but then, moreover, there's a learning value to the students participating.
Randall, can I add a comment here?
Sure.
Yeah, so I just wanted to mention that at WinLab, we have always valued this training with multidisciplinary or at least system-oriented thinking. And many of our students go on to work in specialized RF, wireless companies, and more recently with companies which may have something to do with spectrum. But, so as a whole, it's important. And one way we do that is by engaging with faculty like yourself. And Bill Lair has been a regular person at WinLab Research for the last 10 years or so. So we do have more of an economic perspective reflected. And in terms of hands-on training too, we found that there's a summer internship program that works really well to train some students in aspects of this. But all that being said, I think Spectrum still doesn't have the critical mass of student research, and student industry-sponsored projects would be very important for making this move forward. And I think industry becomes truly interested when it becomes clear that it's something that will go into their product or at least benefit aspects of their product. So we haven't seen that groundswell yet. So there's more work to be done in that sense.
All right, great. Thanks, Ray. While we're on this subject of multidisciplinary, I think another aspect to that, which we see in SpectrumX is looking across different application domains for spectrum. So I think a lot of us come more from on the panel here come from a communication background, but there's science use of spectrum, there's radar use of spectrum. What are your thoughts on encouraging collaborations in that way and challenges that you found? I'm gonna go, Eric.
Yeah, I'm kind of like I'll be my sarcastic self.
That's why I invited you.
Yeah, I know. We can't have one extreme, which is everything must be exclusively licensed so I can go sell it to people. Or the other extreme of I can't possibly either give up this spectrum or share this spectrum because, that would be the end of, scientific endeavor as we know it. While I was at the FCC, there was a request for an experimental license in the terahertz band. And there was an agency who basically said, no, can't possibly do it. We're using that band for an earth sensing use. There was one satellite, which most of the time was on the other side of the Earth. So you had the whole Earth was and no, this is not ground penetrating radar. So, compromise was reached. But, to have people learn the issues that are going on in the environment, and come in with an open mind.
All right, great. Agreed, fully agreed. Anyone else want to take a stab at that?
Just want to say that there is a lot of opportunity with the work that's going on in this space of the national radio dynamic zones. And really, these are use cases that are beyond just communication. So, you're protecting radio astronomy, you are trying to coexist with other operators, etc. I mean, it could be emergency personnel and so on. So there's lots of very interesting experiments that can be done. So I think we all as a community could educate ourselves on the opportunities through the national radio dynamic zones once they mature. And that'll be a forcing function. New programs on the NRDZs could be a forcing function to bring these communities together.
All right. Thanks, Kaushik. So I think Nick teed up a question. I think it's almost also tailor-made for Eric. Do you want to?
Oh, I'd definitely jump in on that one. For those without the chat, he's asking about, to strengthen policy engagement, should we be looking to engage more with IEEE USA? And first, the intro, most people on this call are familiar with IEEE, but might or might not be familiar with IEEE USA other than it's got great insurance. And I have seen the surveys for the non-academic IEEE North American members. I think 60% of them are members to get the insurance. And then, oh yeah, they do this publication thing, and yeah, I might go to a conference. IEEE is a global organization. We represent all electrical engineers and affiliated fields. IEEE USA, focuses on the needs and interests of the American members of IEEE. And so one very important activity of IEEE USA is policy. And I would encourage, I think it might have been today, was Congressional Visits Day. Obviously, you're not there, you're here, but in future years, I would encourage people to do that. And IEEE USA has a communications policy group, has workforce development group. These are all areas, and we have published, in fact, your own Mike Marcus has contributed many papers you'd be shocked to hear on spectrum policy. And it gives, it wasn't just Mike Marcus. It was, the consensus voice of IEEE USA. Another thing Nick asked is, what about beyond IEEE USA? I would again encourage people to look at the Next G Alliance, which is focused on influencing what's going to be in 6G and beyond. It's run by ATIS, which is a standards organization. So the last thing they would want to do is compete with itself. They're a founding member of 3GPP. but we also want the standards to kind of reflect our values. And some of our values, speaking to this audience, are things like spectrum sharing. Some of our values are things like unlicensed spectrum. And so again, if these things are important for you, important for the results of your research, I would encourage people to get involved because that's the difference between having a journal paper that may or may not get highly cited, but you can't explain to your mom versus, the fact that you can walk around with a phone and it works everywhere. I helped make that happen. That comes through the policy side. So thanks. Thank you, Nick. That was a great question. And Aylin did point out that CVD was last week and that she was there. Many people were there. So again, encourage people to look at that. I have another pitch, but I will hold on to it because I'll let others, I encourage others to speak up.
All right, thanks. Anyone else have thoughts on other organizations like IEEE USA or NextG Alliance that, as a community, we should be more engaged with, or as a center for SpectrumX?
I will say the IEEE USA, this was my first congressional visit day, and I kind of, I had to be convinced, let's say. But in the end, it turned out to be super interesting. And at least the senators I spoke to pretended to listen, which is like and I think they're actually, I came away thinking they are listening and they have good staffers that are taking notes. I came away thinking nobody is super happy with the current uncertainty. And it's, the more we show ourselves, and all of you who are US citizens, who are IEEE members, are by definition paying $49 to IEEE USA. So this is one sort, they do a very good job organizing, training you, and also getting all of these appointments, which is the harder part of the situation. So I highly recommend next year everyone to go to the Hill and speak, because they do like to hear from experts.
Oh, thanks, Aylin. Great.
And actually, I will make the pitch. Most of us here are or have heard of IEEE Fellows. IEEE USA has a government fellows program. This is a program, you do have to have a PhD or getting a PhD within the next year. Tends to be more like new PhDs and older people, but there are also mid-career people doing this. And basically, if it's a very competitive process, if you are awarded a government fellowship, basically IEEE will pay you a stipend for you to embed either in a congressional office, the State Department, I guess no longer USAID, but for example, I had one, and that was part of my being in the White House. I would strongly encourage people to consider doing that because and you can look up an article I wrote for IEEE USA Today's engineer. The typical staffer that Aylin was talking about, the person with the portfolio that has Spectrum is going to be their science advisor. The science advisor typically is someone who just got her bachelor's in biology. So it's a science. So she obviously knows everything about science. And by the way, she went to college. So she also has the education portfolio. So they are desperate for getting expertise to come in and help advise them. And somebody just put in the link for CVD, and on that same website, you can find the Government Fellows Program. Thank you.
All right. Thanks again, Eric. Anyone else have thoughts or comments about this? Or we can move on.
And maybe I want to just reverse and a little bit understand how did, let's say, the CBRS went down in some sense, right? I think that could be a good way for us all to learn as well. And maybe, Eric, you can comment on that, right? That would be a useful thing, like how to influence policy as such, right? And maybe a short overview, maybe it's long enough that it may take the entire hour, but yeah.
Yeah. And I don't know that I can do it justice. And we wouldn't happen to have Michael Calabrese on the call, would we?
He was on yesterday for a little bit. I don't know.
Yeah. In truthfulness, although, it's hard. I'm a professor. It's hard to get me to shut up. But there are people who could give a much better explanation. But while we do have a captive NSF person on the call, I hear from the FCC, NTIA, other federal agencies, why don't we hear from academia? They hear from me, they hear from Henning, but we also served in the government. We found out it's really easy, actually, to comment on like FCC proceedings. And I can even say, there was one proceeding where I was quoted 12 times. 11 times they say, yeah, Dr. Berger mentioned this. He's right, but we disagree. And there was one time where in that same order where they said, yeah, he's right. And because of that, we are changing our mind on how we're doing something. So it's still policy. They won't necessarily do everything you suggest, but it can influence public policy. And so the plea is NSF, they ask for your CV and they ask for basically give us your highly cited journal publications. And so not a surprise, I've been on T&P committees. Well, how many highly cited journal articles do you have? And so when someone is tempted to respond to a proceeding, when someone is tempted to work on a policy paper, they're like, is that going to get me tenure? Is that going to get me promotion? No, it's not. Well, I might do it if I get to it. If the NSF said policy input was a factor, and by factor, obviously, I wouldn't want it to be 30%, but if it's a 1% factor, if getting a standard published and adopted was 1%, I think you'd see a lot more academic participation overnight.
Good. That you actually jumped. That was sort of
I know, but I couldn't. I thought it was the right point.
Yeah. How to encourage faculty to be better engaged in policy. This is something as a center we've spent a lot of time thinking about and talking about. And Eric just put out one suggestion. I'm curious if other people have thoughts.
So I have one thought on that, Randy, and hopefully SpectrumX can be an advocate for that. But if there are, other government representatives, hopefully from FCC especially. So the thought here is that academics in general want to be part of this whole spectrum measurement, activity, sensing sort of movement, right? But we would love to do this. We would love to become data collection centers ourselves. We have such large access to student body who's equally enthusiastic. What's stopping us is awareness and opportunities on for example, how does a university become a spectrum innovation zone or lead efforts in applying for one? And is there a streamlined process? Is it just a one-time assessment that happened where some select places were designated such activity zones, and then there's no further way, there's no open call where people can apply for this, can offer to become and be more engaged with the FCC and with the other agencies in making a case for this. So that's the thought I have, that we would love to be more engaged at the policy level as well, right? But enable us as universities to become equal partners in that, right? Just one other thought, since Eric, you mentioned this thing about the CB, though, I think NSF is a little bit open, though, right? They do say 5 relevant products. It could be the best journal, or it could be a website that is probably doing citizen science for. So, but yes, having incentives to academics will definitely help more, right? Especially tenure and promotion reviews that happen. Nothing to do with NSF, but also internally, what we do in terms of recognizing contributions.
So, right, Dinesh, did you have anything to add?
I think I am also a learner, to be precise here. I think Kaushik is on point on 2 things. One is the awareness of where and how to contribute, right? I think generally if we create a web page from SpectrumX where we sort of just put it out exact details of, hey, this is how you do contribute, right? Okay. And maybe some stories and blogs around how did CBRS went about, how did this happen, right? I think that would be really, really positively motivating everybody here on as academic side goes, right? I think it seems like Dipankar also has some good pointers for us to consider on the chat, right? I think, that would really help, right? The one other point I want to sort of say is perhaps we need to also tie up the economic model, right, to a lot of our efforts, right? In the sense that I'm talking about broader economics, right? In the sense that, like, not just the economics of Spectrum and its economics are, let's say, very beaten down at this point, right? I think they're very clear, right? The point is that how does it contribute to the larger ecosystem? Earlier, we were discussing how IT has influenced, let's say, the entire GPU and the ARM and the computing world, right? Okay. Infrastructure on this side, right? I think we, as, let's say, users or providers of spectrum related resources and understanding, right? I think we need to tap into what is the real world economic, right? And where does that influence, and how do we get the pie of the share, right? Or how does the companies which are doing, let's say, a lot of wireless related things are making big bucks, let's put it this way, right? And that then translates to the overall ecosystem in some sense of the wireless research gets promoted at different universities. More universities are hiring people in wireless, and that's how sort of we will try to get more people to contribute to this ecosystem, right? I think I had a very funny incident that a colleague from somewhere, I don't want to comment on that, but they said that we are in sort of like an era of where it's maybe another 10 years, we will just be interested in doing things, or 20 years, right? I don't want to quote them exactly, but roughly they were saying that there is a waning effect on wireless right now, right? And then I think this is where we need a sharp economic model connected directly to a lot of our research activities, right? It's not just to influence policy, but to just broader economy. How do we influence that, right? That could be something I would like everybody to think about, right? I think, and more to be preciseness, I think somebody was asking that there are not enough platforms, or the platforms for SDRs and ML are like very, very bad or not good enough, right? At this point, this is because there is no, let's say, primary ecosystem on the other side, which allows for them to be built at good scale and good production type settings and so on and so forth, right? Okay. We have to find out where in a scale these would be used, right? And maybe it's connectivity, right? Let's just build connectivity using SDRs, right? It is not done today, but maybe that is a way to do it, right? Or whatever that is, right? And maybe it's sensing, right? I think, but that has to be done at scale so that the economy supports the entire ecosystem at some level, right? Maybe a long-winded way of saying, yeah, we need economics to work for us, right? Okay, it's not working, or maybe it is, I don't know, to be precise, right? Okay.
All right, thanks, Dinesh. I just wanted to add something to this, the discussion about, incentives for academics and recognition. I guess one maybe parallel is I've known from talking to people, I think if you went back 20 years at most universities, entrepreneurial activity wasn't considered in P&T processes as a positive. That has definitely changed. At least at Northwestern, I'm assuming at most universities. so it feels like there is these things can change, even though at universities it feels like, it's very slow sometimes. And so, participating in public policy, making contributions to public policy perhaps has a trajectory like that. That might be something worth looking at. All right, so I wanted to go back. There was a comment in the chat a while ago that I thought we could address from Evariste. It was saying that RF plus ML is still in its infancy, and that software-defined radio hardware evolution is not always proportional to the contemporary challenges such as AI, ML, and deep learning. And so how can the SpectrumX community, the broader academic community, help persuade SDRs to industry to keep up with these changes and help address that? I think Dinesh, you or Kaushik maybe?
Sure, I can start. I think the answer to your question, Everest, is that you should start a company, really, right? Okay, and build these nice package together SDRs with, let's say, computing, right? But I have to say, if you look at Kickstarter right now, there are several variants of SDRs out there. One in specific I would make point of mentioning is, I thought it was pretty cool. I don't know, I have not tried it yet. There is a company called Fairwaves, and they are building this XTXRX, right? It's pretty neat. It can do all the way up to 8-channel massive MIMO, and it's just a PCI card which plugs into pretty much your desktop or Raspberry Pis or other things, right? I think the point is, I would say that, like, one, the awareness of these is like slightly limited, right? Two, like, nobody sells a complete, like, hey, here's a desktop, right? Like, you can go buy today OAI box or something like that, right? Which has a package together desktop with an SDR, which acts as a 5G base station. It gives you nice dashboard, and you can just do click, 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 right on it, right? I think similar platforms do not, let's say, have not transpired in the larger ecosystem of SDR research, primarily because what is the real use case, right? For OAI box, the real use case was private 5G, right? Like, hey, you can just take this, put it up, you can provide connectivity to people you have around you, right? I think if you do a sort of, let's say, a startup or whatever that is, right? Okay, variation of FIFO, C3s, and so on and so forth, which truly focuses on creating economic model for yourself and at the same time providing this platform for research, right? Okay, I think there has been some interesting efforts on putting together, for example, Snapdragons together with some of the SDR chips onto one platform, and that would give you truly the power of amazing computing, which Qualcomm is known for in the world of SDRs, right? I think there are like these niche efforts I see here and there some companies are trying to put together, right? I think we as an ecosystem also has to support them by becoming customers, right, at some level. So that way this will become more faster promotion, right? I think maybe I would say ETS has done a good job, right? But it's also, I guess, because of lack of, I don't know what's the reason, but this development pace has slowed right now, right? And we need some more energy on that, right? I think, yeah, I guess really I'm just saying that we need to just figure out more economic startups and whatnot, which can essentially build it and then give it to us as well for doing research, right? Okay. Or maybe NSF needs to support more of SBIRs, which are along those directions where they make these boxes, right? Which I think I can just buy and then do SDR research for myself, right? Both on computing and sort of SDR side.
All right. Thanks, Dinesh. Anyone else want to add to that?
Well, the importance of this question is not lost on the SDR manufacturers. And, I mean, there are some products that are already in the market. So I don't want to perhaps take a side here. Many of them are close friends and collaborators. There are some SDRs which have GPUs soldered on the board itself, right? You can buy today. And there are some more coming in the near future. So I think I'm very optimistic that we will soon see more and more of these new platforms being built and deployed. But so I share Dinesh's optimism as well.
I just want to make a point here that there's a lot of power consumption issues that come up anytime you try to replace a chip-based architecture with a all fully software one, like we're trying to do now for ORAN, for example. So there's a project that we have started on power efficiency of the ORAN architecture. And there's kind of a huge gap that has to be filled, and most of the mainstream wireless industry providers will not go to a solution that requires 10 to 100x the power. I don't know the number yet for ORAN, but it's a pretty serious consideration. And a lot of these things are good for labs where you can run a few of them and do a small demo. But I think, some companies like Ericsson would hesitate to change their platforms too much in a short period of time. That's just a concern.
All right, power, definitely power, always a concern. So we're approaching the end of our time. So I did want to pivot for one last question from me, and if we have time, we can take a few more. And this was, another thing we talked about was the spectrum research community. So I think one of the things that SpectrumX as a center has tried to do is build up that community. I'm curious to hear your thoughts on sort of the state of the spectrum research community, however you want to define that. And what are challenges to growing that going forward? Anyone want to jump in on that one?
So Randy, is the question, how do we further and expand the spectrum research community, and what SpectrumX could specifically do towards it? Is that so? You're tasking, give us homework? Is the question?
That's right.
Look, I think SpectrumX is doing an amazing job, right? It is one of the unique institutes that is at the intersection of technology and policy and use cases that are bringing these very different communities together, for sure. My humble suggestion would be is to if there are certain, and we are actively discussing in the chat as well, if there are some active community benefiting outreach efforts that SpectrumX could lead and we could be part of, for example, a streamlined process to apply and receive a permission for FCC innovation zones, right? That's one example. But there could be other things like maybe creating community challenges and interesting spectrum data sets, or this kind of activity that brings people together, but spearheaded by a central, a beacon of light. Those are the kinds of activities that I think would be wonderful. I'm sure many thoughts will come to mind, but I'll let the others speak first.
All right, thanks. No, great suggestions. Anyone else?
I may have a very concrete pointer, right?
Okay.
Maybe my selfish concrete pointer, but let me make it. So I'm sure everybody has seen some RF SOC platforms, right? They are amazing, right? They do 5 gigasample on DACs. And like basically we won't need SDR. We'll just connect directly to them, to antenna, and that will be it, right? And we'll probably put some amplifiers to them, right? And maybe some up converters if you want to go to 612 or whatever frequencies, right? All the way up to 24, right? So point is following, right? Simply, I think if we develop as a community a good SDR out of that, right? Okay, that would be perfect, right? I think I would really love just having that, right? Okay. Basically take RF SOC and make it really good high streaming SDR and give me that, right? I think if we achieve that as SpectrumX, I think it's successful, right? I think, and make it super popular, conduct tutorials, conduct how to use it, right? And let the community build new use cases, applications around it, and so on and so forth, right? All the way from communication to sensing, right? I think I had this conversation with one of the colleagues last week. I still want to have task from that. I just remembered, but I think she was also looking into this, right? And she was like, "Yeah, this is it's a challenging platform to use, to be precise to everybody. We have been trying to use it for the last 6 months, and we have had some like significant amount of trouble getting it to work in a reasonable form and fashion." Yeah.
All right. Anyone else? All right, nice. Okay. So yeah, that was, I guess you guys answered that from sort of a SpectrumX point of view, but I'd also like to think it just as kind of the larger Spectrum community. So I know Eric and I were involved with DiceBand last year, which was relatively successful. It's still a relatively small conference if you think of that as sort of a home conference. Is this the right size? Should Spectra, should we be attracting a much bigger crowd, or is this are we a niche community that's spread out, and then some of the other people on the call might have other home communities that they're doing radar, they're doing radio astronomy, for example. Do we need sort of a home base where everyone comes together? Any thoughts?
So maybe I'll make one point, right? I think this is what I discussed together with you, Randy. I'm sure I forgot to make this point until now, right? In earlier. I think I was just explaining this that right now, the way we interact with our environments, right, is precisely with a lot of our watches and phones and whatnot, right? And largely they are packed with tons and tons of compute, right? And this tons and tons of compute is essentially designed to compress the data we send over the network, right? Okay. Primarily because sending such large amounts of data over the network would really, really kill your device, right? In terms of the battery and the energy it takes, right? So really, I think we need to think from user's point of view, right? From my point of view, what makes sense is that my phone's battery should last very, very long, right? Mm-hmm. So making connectivity extremely energy efficient, right? It's as much as if I tried running a model on my device, right? It should consume the same power if I just backhaul the real IQ or whatever, like real images or videos directly to, let's say, my Wi-Fi access point or my private 5G nearby, which has decent amount of compute. It does the same computation and gives me result pretty much like as if I'm just running everything on locally, right? Okay. We need to power up these sort of use cases, right, in next 5 years, right? Because I think every time you think about it, there is a race between computing and communication, right? One can say it's a race, maybe it's also a nice way to think about it, but this is really where we are, right? I think the way to make this more relevant, right, we have to really catch up to this, and more when I say we, just a broader ecosystem of academics, industry, and everybody together coming out and sort of figuring out how do we like beat this ecosystem, right? In some sense of the amount of compute power you can pack on a single device, it's just going so fast. How do we grow similarly at fast pace scale of taking that data off and then sort of doing in a local cloud or edge or a more mere central cloud, right? And it comes down to energy, right? If you give me or if you give an app developer an energy efficient solution, he would pivot to that, right? Because it just makes sense. It will elongate the battery. Everybody in the ecosystem would support that, right? Or at least the users would like that, definitely, right? And then you can push the ecosystem in this direction a little bit, right? Where this connectivity becomes really a central piece of all of this ecosystem, right? I will pause at that, and maybe I think I'm just making a broader comment of spectrum and its use, right? And I think we can think of sensing as well on the other side. How do we use a broader amount of spectrum to sense things, which I think we have like dedicated sensors for, right? That could be other way to think about it. But maybe back to you, Randy. Yeah.
Okay. Yeah. Anyone else want to chime in?
I just want to conclude with the point I was making at the beginning, which is that we really need a mutually agreed architecture. It doesn't have to be perfect, but should have appropriate partitioning that allows different industry and academic components to be integrated and tested. A key thing which Kaushik brought up is that of having a framework for doing data collection and being able to query that data with appropriate semantics. So there are a lot of these sort of software interface-oriented projects that need to happen. And there has to be more or less a general agreement across the community, and things like the IEEE standard 1900.6 5, I believe, is an example of some groups which are trying to get a universal language for spectrum use. And I think all the good results can gradually go into that framework because you have a more flexible and agreed upon language. So it's a long topic. So thank you for the time today.
All right. No, thank you. So
I
we
just want
are
to just say,
yeah.
just one quick word in closing that there is absolutely a need for central coordinating institutes like SpectrumX in this whole. So if you look at just this panel, right, there's a mix of systems, ML, policy, core wireless, even reflected and economics even within this particular microcosm of the community. This sort of aggregation and coordination is not going to happen if you let it be. The entropy is just too high. So you need a forcing function, and we need these central institutes like this. And this panel itself is an example of why we need such central coordination. I'll stop here, but thanks again, Randy, for your invite.
No, and thank you. That's a great comment that I agree with. I think I see Nick up there. I'm sure he agrees with too. Eric, you have any final comments?
Yeah, no, we have forcing functions, but it's also just the right thing to get, these multidisciplinary groups together. In the chat, Nick's been talking about, maybe doing workshops. I can say the NextG Alliance has been doing a bunch of workshops on something we touched upon, which is the application verticals, because we're coming up with all this neat, cool spectrum stuff, but at the end of the day, what are people using it for? Why would they want it? Why would we want to give it to them? And that way we learn, kind of by looking at the applications, oh, wow, never thought that was a need, and I've got an idea of how to satisfy it. And then, as Dinesh said, and then we go form a company. And the NSF has a lot of paths for that. I know CCI has paths for that. And riffing on something that I think Ray talked about in the chat again, I'll put in the pitch for the NextG Alliance. There are a lot of marriages born of academics and industry sitting at the same table, coming up with projects that industry needs and thus will fund, and academics have ideas and want to do. And there are, the NextG Alliance, there are some IUCRCs out there like Whisper that, we can bring all these people together and actually get it done. So thank you. Yes.